All right, we are right at the 45-minute mark, so I'll go ahead and get us started. Welcome everyone to the session, Forest and the Trees and Grass, Procuring Climate-Smart Mass Timber and Bamboo. While not necessarily a new material, mass timber is growing in popularity as a lower carbon alternative to concrete and steel. The session will dive into what designers need to know in order to get mass timber and lumber products right, and what innovations are occurring that we can likely expect to see in the future marketplace. If you're looking for AIA continuing education credit, the learning units are showed here, and we'll follow up with a survey about how to submit your member number for credit. And if we don't get to all of the Q&A during the session, we'll ask our speakers to answer that later on, and we'll post it to the CarbonPositive website, along with recordings of the session. Those will also be posted to the CarbonPositive website. With that, it is my pleasure to introduce our moderator for the session, Jan-Peter Koppitz. Jan-Peter, or JP, is an associate at Arup, where he has worked since 2000 in their London, Madrid, and San Francisco offices, and is now currently in their Berlin office. A structural engineer, JP has been actively challenging clients, collaborators, and contractors to find and implement solutions in timber. And with that, JP, go ahead and take it away.
Thank you, Lindsay.
You should be able to share your screen. Yep, great.
There we go. So thanks everybody for joining us for this session of Forest and the Trees and Forest and the Grass, you know, as we want to focus on timber and other possibilities like bamboo. So where do materials even fit in? If we take a step back, you know, me as a designer, as a structural engineer, tackling you know, zero carbon design. This is kind of the ice cream cone design approach that I like to use, where, you know, building use and operation and building materials both go into the ice cream cone to give us a carbon neutral design. And so focusing on the building materials, where do we as designers, how can we actually influence the correct choice of carbon neutral materials like wood and bamboo, right? If we look at the design phases, which is where we are predominantly involved, right at the very beginning during conceptual design, we can, you know, explore the design benefits of using sustainable materials. We can establish benchmarks, and we can actually also identify material strategies, right? Be it wood, be it bamboo, as we'll investigate in a little bit and hear from Rod and Troy. And so for us as designers, it's really important that when we want to identify materials, that there's certification systems and approvals and systems in place that we can, you know, rely on to actually get us these sustainable materials. Species identification, supply chain, all those things, we need to rely on an effective system. And so, right, when we want to actually specify at the beginning of our project, sustainable forestry, sustainable wood, or sustainable bamboo, you know, how do we actually go about it? How do we select these, what are the criteria? And like I said, what are the certifications that we can rely on? And so to help us with these questions, when is wood, for example, actually sustainable? Or how can I actually specify other sustainable materials like bamboo? So for that today, we have Rod Taylor and Troy Carter here. Rod Taylor works at the World Resources Institute, is director there, and he aims to ensure that truly sustainable wood products make it to the construction sites, make it into projects. And we also have Troy Carter, who is intent on making bamboo products a primary global construction material, and will tell us all about the sustainability and other aspects of bamboo products. And so I'll tip over to you, Rod, to start us off with the first presentation.
Thanks, Jean-Peter. Hello everyone. I'm going to present a perspective from the forests. I'm not going to pretend I know a lot about design and specification of construction materials, but just try and give a forest perspective on this. If you go to the next slide. I think that first slide is a little bit about what I was trying to illustrate with this slide as well. That not all forestry activities and not all wood harvesting is good for the planet. So we've seen these iconic fires. There's a lot of debate around the extent to which they're a product of bad forestry or a product of not enough good forestry. But the fire issue is certainly a hot one right now, literally. And then this is our flagship product is something called Global Forest Watch. And it's set up to help anyone anywhere check out what's going on the world's forests. And this is an animation of we have these pink pixels, which are deforestation or forest loss occurring, and they refresh about every couple of days. So the animation you can see here is a road being punched into a protected area in Peru, and it's an illegal logging operation. If you click one more forward, thanks. You can see what was actually going on there. This is a convoy of illegal logging trucks building a legal road and taking money out of a protected area. So this kind of stuff can go on, and things like Global Forest Watch are intended to shine a light on the far of forests where people try to get away with a lot of bad stuff. But then, next slide, turning a bit more onto the positive side of things. This is a schema of how we explain our forest strategy. And I thought it might be useful to just set the scene here, because we see the world as divided up into this spectrum of intact forest right through to completely deforested and denuded land. And if you're looking at a land management strategy, you're basically trying to protect the stuff that's still there. You're trying to maintain through sound stewardship the forests, particularly production forests, and that's where the certification schemes have a big role in verifying good stewardship. And then finally, because we've lost perhaps about a third of the world's forests since the last ice age, there's a huge restoration agenda, which can be anything from restoring forests to something like a natural condition, or just simply making really degraded farming land, improving the soil and water and so on, so that at least it can be productive again. And agroforestry is an interesting mix of pure forestation and agriculture. Next slide. And then if you get into the complex business of when is a forest a sink and when is it a source of emissions, and I'm emphasizing this because we're looking at the carbon aspects of all this. In broad brush terms, you have two forms of land use change. The positive form from a carbon perspective is on the left side of this slide, which is afforestation. And that can take the form of planting trees, or it can be fencing off areas and letting them naturally regenerate. So the most effective and least expensive form of reforestation is natural regeneration, when you can let it occur. But in many places, the seed bank is so bad that you can only really do that through tree planting. And right over on the right side of this, we've got the worst form of land use change, which is when we convert forests into other land uses like agriculture, mining, cities, and so on. And whenever we do that, there's usually emissions associated with the biomass that's taken out of the forest and the gradual decline of the vegetation and soil left behind. And then we have this interesting thing, which is by the acronym HWP on this slide, which is when there is harvesting, it's generally an emission, except to the extent that that wood can be stored in hardwood products. And that's the key point of interest from the construction industry, the extent to which by using wood, we're not really creating emissions, we're storing carbon and allowing the forest to go on sequestering more carbon from the atmosphere. Next slide. So this is just, we've been doing some modeling using our Global Forest Watch data and others. And if you look across the world using this model, this is over about the period from 2000 to 2015, you can see that there are areas where forests are a net sink, and then the kind of browny red colored areas are areas where the forest sector is a net source of emissions. And mostly that's associated with deforestation. However, production forestry is an interesting mix because obviously you have cycles of harvest and regrowth and harvest and regrowth. And 15 years is a relatively snapshot for the far northern forests of the boreal, whereas it's potentially 2 plantation rotations in the south. So there's a lot of averaging done here. But if you look, for example, you'll see some parts of generally the activity in the northern hemisphere is less about deforestation and more about whether forestry is ultimately in balance in terms of adding carbon or reducing carbon from the forests of the world. Important to remember that forests remove about 30% of fossil fuel emissions every year, and to the extent we can expand forests and plant more, we can increase that percentage. Over, next slide. Then, if you come out of the forest and go into supply chains, the whole issue of carbon impact becomes a whole lot more complicated because we have carbon emissions associated with manufacturing. You have the extent to which a product can be recycled, and with most forest products, there's the potential for cascading use. This is when, you know, a wood fiber might be used initially in, say, furniture, then it might be used a second time around in some form of glossy paper, a third time around in some kind of carton, a fourth time around in something as rough fibered as an egg carton, and so that cascading use, so you can get multiple use out of the same virgin wood fiber, is an important part of the picture. And finally, there's this competition between use of wood as energy or as materials. And so there's all kinds of feedback loops and trade-offs. And the industry itself burns a lot of wood to power its mills and manufacturing processes. Next slide. So how do you make sense of all that? We've got sources and sinks in the forest, and we've got these other complicating supply chain factors. So I'm part of a project with a few other organizations that's being funded by the Good Energy Foundation. And we're calling it the New Forest Economy. And the idea is to really get to the bottom of when wood products are good for the climate and are sustainable, and promote more use of wood in those contexts and less use of wood in the context where wood is actually bad for the climate. And we're using this 3S framework as a way to do this because there are all kinds of systems out there that are focused on the forests, and there's all kinds of life cycle analyses, but we haven't been able to find any system that really combines the full picture and gives you a complete picture of the impact of a product. And so our aspiration is to build out some tools around this 3S framework. And if you look at that schema along the bottom there, where it's supposed to depict a forest that would be harvested every 20 years. And a big assumption behind this is that it's a forest on degraded land, not a forest, a plantation or something that's replacing a natural forest. Wherever you have conversion of natural forest to a plantation, generally you create a carbon debt that you can never recover. However, if you're planting on land that was cleared or degraded some time back, you generally get a positive momentum. And at the end of each harvest, you'll see that the carbon stock in the forest will go down, and the extent to which that can then be stored in wood products or for other, or in substitution, you can get a net positive effect. And so I just explained briefly, the sink is whether the forest is managed in a net carbon way, and there are several ways that can be done. A lot of selective forestry operations are also responsible for maintaining protected areas within the forest estate. Those are generally positive for the sinks, and you can also reduce maximize the biodiversity balance between that carbon and production. So that's what certification is all about, making sure that the sink is positive and that the forest management is sustainable. Then we have what we call the storage fraction. storage matter, which is looking at how much of the carbon ends up in a long-lived product. If it goes straight into paper or something like that, the chances are it might be in the atmosphere in as short as 1 or 2 years by being sent to landfill or something, or burnt in an incinerator. So the more carbon that can go into long wood products, including things like mass timber, then you're getting not only the sequestration in the forest, but also long-term storage in the product. And finally, there's the substitution element, to the extent that wood is a competitor with steel or concrete or plastic, and the extent to which those other materials might have a higher carbon footprint than wood, then you're getting another gain, because you're eliminating the emissions that would have been associated with the material that's been substituted by wood. So our intention is to develop a tool so you can calculate the full carbon impact of a forest product using this framework, and then combine that with things like certification to make sure we get the right balance in the forest with other objectives of forestry, such as biodiversity, local livelihoods, respect for rights, all those kinds of things. And we hope then we'll have the full picture on products, and then the project really is aimed at reducing the barriers to uptake of wood. So that relates to how things are specified, policies, subsidies, lack of knowledge about engineering qualities of wood. All that stuff will be directed towards circumstances where forest products come out looking good on this 3S framework. That's all from me, thanks.
Thank you, Rod. And now we will continue with Troy's short presentation. Over to you, Troy.
Yeah, thanks for the setup, JP. So I love one of these. There are 2 slides in your presentation, Rob, that were powerful. One was the image of this road being plowed through the Amazon, basically, and another was just a global map, and there were some particularly strong red areas, particularly around Indonesia, Southeast Asia. But one of the motivations for building with bamboo is that mass timber is awesome, right? Like we should be building a lot of tall wooden buildings, sequestering carbon in the built environment. But the reality is that won't be the case for most of the world. And the reason that is that, North America, Scandinavia, Western Europe, they're doing a really good job at certifying sustainable lumber. We have FSC certification, and we can be pretty compliant with those methodologies because there's pretty good oversight. However, the Amazon, Sub-Saharan Africa, South and Southeast Asia, these are places that in many regions have seen up to 100% deforestation over the last 50 or 60 years. And really, go to India, go to Indonesia, go to the Philippines, most places don't have any trees left. And so mass timber won't be an option for many of the economies that are growing the fastest and populations that are growing the fastest. So we need alternatives, because if we're going to build all the buildings that are required in India and Indonesia and Bangladesh and Kenya and Ethiopia over the next 40 years, we won't be able to build them out of wood. And so they will be built out of concrete and steel. And if that happens, the planet's going to hit some major climate thresholds that we really don't want to hit. So this is where bamboo comes in. In regions where there's been historical deforestation, it's a highly fast-growing material, grows at least 10 times faster than any other tree that we know of. So it has a lot less land use. The more you build with it, the better it is impact for the climate. So it grows right back as soon as you cut it down, which means there's an inherently regenerative aspect to the plant. Unlike cutting down trees, which when you cut down a tree, usually the root system dies, there's soil or erosion, so the full life cycle analysis is actually pretty sketchy on a carbon side. And it's also a technically superior material to most wood uses. It's at least 2.5 times as strong by weight as steel, which means it's around twice as strong as most woods by pretty much every metric. And due to the fiber characteristics and treatment of bamboo, it's also fire resistant. So there are some major design innovations that we can have with the material that we actually haven't seen yet. So just a brief overview on how it's actually made. Take a round pole of bamboo, you slice it up into long, thin boards and plane them, you treat them, and laminate them into pretty much any layup or configuration that you can have for modern engineered lumber. That means plywood, boards and dimensions, or CLT, LVL for large mass timber products. And part of the innovation that we're doing at RIZOME is bringing this product to industrial scale and build a global supply chain that's as reliable as the lumber supply chain. Just brief on carbon sequestration. So one of the ways that we can help solve climate change in the near term is planting a whole lot of bamboo in coordination with native forest. We don't want to live on a bamboo planet, but it does have such a fast turnaround with reaching full maturity for harvest in 7 years that it can provide both a short-term building material and also just grow super fast. So just a comparison, a 3-year-old Douglas fir is a couple, pencil widths thick and, maybe a meter or 2 high. A 3-year-old Dendrocalamus giganteus can be, 30 to 40 meters high with multiple culms, multiple culms that 200 to 300 centimeters across. So like a really big plant. So what's the trajectory that we can imagine bamboo taking? RIZOME isn't the only company doing this. There are others that are starting to enter the supply chain for structural materials as well. But just internally, our own goal is to sequester 10 gigatons of carbon by 2050. And that means planting about 1 million hectares of giant timber bamboo, that's Dendrocalamus asper, giganteus, and Sinicus. There are a few other species that may work in other areas in Latin America, like Guadua angustifolia. And that will require about 1,000 rural processing facilities globally. So it's a big operation. Like the amount of wood that we use in the built environment is almost too large to conceptualize. But bamboo has such a dense biomass production curve that we believe it's a pretty strong link in how we start addressing the climate crisis. So here's contact information for talking about strategic partnerships, collaboration. We might run like a design competition over the next coming months. So for concept renderings from designers or architects, you can just reach out. And we're also taking off-takers starting in 2021. But maybe we jump into question and answer also for the whole panel. And thanks a lot.
Thank you, Troy. That I personally have also a couple of times looked into using bamboo, especially as as designers we do work worldwide, and as you mentioned, North America and Europe, they've got robust systems of certification, or even various ones where there's still discussions, but as soon as you work in other countries, then it always brings up the question, is it better to go local material, which if you do stick to wood, which isn't certified, or do you actually go to a non-local material and get it from further away and it is certified, right? Yeah. Or do you actually, then bamboo would help to answer that question, because that could possibly be a local resource and then also, sustainable.
Totally. The equation for Western Europe and North America is a bit different, just because there actually is quite a lot of wood. But the equation for Indonesia, Bangladesh, places like that, that are seeing really fast population growth, we don't want to be importing trees from Scandinavia and taking them to India anyway, and that the economics of that just don't work out.
Right. Yeah. I'll jump over to some of the questions that we've received, because this one is, I think there are some good questions that came up. The first one is also one that I hear a lot from clients and architects when I'm in discussions with them. If we convert, if we start actually working with wood and we convert all new buildings to wood, would we even have enough supply? Would there be enough wood source to cover for that? As a designer, I personally think that buildings will not become 100% wood. There still are other structural materials, steel and concrete, which sometimes are just more efficient structural systems and can still be used. But it is a valid question. What do you think, Rod?
I think it's a good question, and we've done all kinds of modeling on scenarios where you, for example, triple the world's wood supply and see what happens. The reality is that we have about 4 billion hectares worth of forests on the planet, and we're only actively managing about 1/4 of those for wood production. So in theory, there's of the forests that aren't currently dedicated to production. And at the same time, a big push for protecting 1/3 of the planet. So let's say we protected, half those. There's still 1 billion hectares of forests to manage in some shape or form. And we're also seeing examples of if you don't manage a forest, for example, and let a whole lot of flammable timber come up in it, you can end up with very catastrophic fires and things like that. So I think there's a case for sustainable management of more of the share of the world's forests, which would generate a fair bit of wood. But the really big bang for your buck comes in plantation expansion. And a tropical plantation in Brazil can produce more wood per hectare per year than just about anybody else, because they've got it done so efficiently. In the context of plantations, I think there's enormous ability to try more local species, so growing eucalyptus, because everyone knows about it everywhere on the planet. But we've done some really interesting experiments in Brazil on native species in plantations with maybe 4 or 5 species. You get high productivity, don't get as many problems with pests, and you can use it for solid wood as well as pulp and paper. But the real challenge with plantations is whether they're replacing natural forests or not. And they're also in competition for food production. So they're the 2 big issues of expanding a plantation base. And so if you can expand it on land that's very marginal for food production, for example, overgrazed areas where it's not really suitable for long-term grazing anyway, and where people aren't going to lose their livelihoods, then there is enormous potential to have plantations combined with natural areas as a restoration strategy. So we have a larger production base for wood. So I don't think, if you look at better management of some of the world's undermanaged forests and plantations in the right places, include half the world's wood is used for fuel wood. So there's another big opportunity there if we more people with renewable energy, solar in villages and things. There's another big opportunity. So I don't think the ultimate constraint is the world's wood supply, but it's managing that supply so it's sustainable.
Yeah. And what about on the bamboo side, Troy?
Yeah. I mean, I was going to say to your question, there's honestly no easy answer to this question. Yeah. There's, demand is complex, and also, fuel wood, like that's a complex story. Why do people use wood as fuel anyway? Like it's actually a fairly inefficient, like mass scale fuel source. But maybe bamboo does have a role to play. One is that it's such a dense biomass production. So like if there's 10 times the biomass production, at least as a temperate forest, native trees in Brazil is great as well. However, just the fact that it's an annual crop. So let's talk about just a case example. So we're mostly operational in the Philippines on the island of Mindanao that's pretty much 100% deforested. It used to be lush tropical forest, and now it's denuded grassland that has grass fires every year. Reforestation is mostly non-effective because of the grass fires and because of farmers running cattle on the land right after planting the trees. So one, bamboo can be a great pioneer reforestation species. It survives grass fires. It survives a chomp from a cow. But it also provides an annual crop for smallholder landowners or indigenous populations that are actually faced between a decision about whether to cut the forest down or whether to whether to feed their families and cut the forest down, or whether to like conserve the forest that is part of their love and cultural heritage. And so, while the wood industry is almost inherently centralized, you saw the number of trucks in that picture, there are a lot of trucks and big equipment. If you've ever tried to cut down a Douglas fir tree yourself, you'll know you can't do it yourself. It actually requires large equipment. And that's one thing that I think inherently moves towards reducing land agency for the people on that land if it requires large equipment and centralized logging operations. But bamboo is a little bit different. Like you can have an individual or a family with a few clumps or a few acres of bamboo contribute to a co-op that is actually entering just as sophisticated of a supply chain. Just because it's really light, you can chop it down with a handsaw and move it. So there is something that is inherently decentralized about bamboo that I think does not have the same sort of perverse incentive structure as lumber. Obviously people will build very, very large monoculture plantations. I think that is inevitable, but it doesn't have to be that way. So there can be a mix of native forest, and also what we're seeing with the maturation of the carbon market is that more and more people are getting paid for keeping forests in the ground. So what we're seeing is actually a profitable model for planting bamboo and native forest, and have a portfolio that actually is profitable on the carbon side and provides an annual crop for fiber, for fuel, and for building. So we see it as a pretty good solution.
But is there a danger that the bamboo industry could then end up turning into the palm oil industry, and it becomes so
Totally.
big that it actually leads to deforestation? I mean, that also could.
I would say yes, there is a risk of that, and there's no way around it. We have to make choices as we're the industrialists in this category, so it's really our choice about how we go and implement this in a way. So we do one-to-one native forest reforestation, and hopefully there will either be regulatory or at least businesses that will follow in the same pattern of development.
Yeah. Another question now, moving back to Europe and Scandinavia, where timber is more abundant. There's a question of, supposing this comes from a designer, what is the best way to ensure that the wood you are procuring actually comes from a sustainable forest practice? I guess this is talking about what certification. And I think in Europe, it's also a bit more some of the countries are saying that, well, no, we've been doing this for generations and generations, and so our practices don't need an additional FSC stamp. So what do you say, Rod?
Having been in certification wars for a long time on the competition between the different schemes, that would be a half day's debate on which ones are good for what.
Right.
I think broadly speaking, the certification schemes give you a lot of assurance about what happens in the forest, but they don't cover the rest of the supply chain. They don't look at the other S's I was talking about, the storage, the recycling. Once the wood leaves the forest, the certification capacity, but doesn't look at the labor practices in the factory, the carbon impact of that use compared to something else. So that's why we're suggesting certification is your core safeguard on what happens in the forest, but then we need to supplement that with some other things to calculate is using wood for this purpose in this building climate positive or climate negative? Or if it's climate positive, what is the full benefit when you add in the substitution and the storage and the forestry practice all together? That for you at the moment. It doesn't give you a carbon number.
Yeah. One thing that I noticed that both of what you two focus on is right where our sustainable material actually comes from, what country, what region, what culture. So in trying to help ensure that we actually get the sustainable materials, and what are you know, as you try to ensure that, what are the biggest hurdles that you guys have come up against? Are they economic? Are they political? Are there social reasons? Right? Some countries actually think that wood is a bad building material, and they just don't see that they should be harvesting, you know, forest for the global supply chain if for them it's not a good product. So what is your experience on those hurdles been?
An example of China. China years ago passed a logging ban on most of its forests because they were getting pretty whacked, and basically pushed its supplying offshore. So China's now the biggest importer of wood for just about everything. And it's a great sucking sound because it reaches out into many different countries. And so we've just proposed a solution that China really beefs up its due diligence on wood and soy and palm oil and all these questions. So the question of traceability is key to this, and technology's doing a lot. So I don't know if you've seen Global Fishing Watch, you know, all the fishing vessels are GPS wherever they go around the world, and they get data to put together which fish have come from where. We're not quite there with forests yet, but you know, there are all kinds of ways you can track wood from forest to product, and get, you know, if you really want to know where it comes from, you know, IKEA can tell you where all the wood comes from now. You know, they have all the systems in place to do that. So I think the traceability and the other thing is due diligence in the EU, and there's a law that you can't import wood associated with illegal logging, and you need to do due diligence to make sure it's sourced illegally. So those kinds of things are making it more and more possible. We almost have to know where your wood was grown, otherwise you risk running foul of all those new systems.
Yeah. Yeah, and maybe a little bit on the same trend. You know, global, like we don't have a global carbon accounting system at the moment. You know, the maturation of our tracking systems, you know, it's just happening now. So in 10 years, I think the story for how we identify individual trees, like right now we identify individual clumps of bamboo, each pole, you know, we can track through our entire system. So we know, you know, which clump, which farmer, how much carbon each clump is sequestering, how much goes into building materials. So like super precise, minute detail. And that's a level of detail that wasn't possible even 5 years ago, where, you know, where some rural farmer with a little app on his phone could type in the weight and the number of culms. And that level of detail is now possible for pretty much any forestry practice. It just hasn't really been implemented yet. So I can see like a very accurate I mean, it's not just carbon, but just say like biomass flow through the system. That's exciting to see the movement. More broadly about sourcing bamboo in general, one is that there is not yet a large, reliable supply chain for structural bamboo. There's about $60 billion of chopsticks and toothpicks and cutting boards, and more recently flooring and some other aesthetic uses. But right now there's not a large supply chain for structural bamboo. You know, RIZOME is one of the first companies, but over the next 5 years and over the next decade, we're going to see that change pretty significantly as new structural timber bamboo plantations or reforestation projects start coming online. So one, most people can't source it. You know, if you're one of sort of like the leading designers or developers, you know, give us a call. We can help you implement it now and over the next couple years. but it's more just a future picture. Like we're playing on a 10 and 20-year trend, which is we can see the global need for this material. And it's a pretty tricky thing to line up all the dots to create as reliable a supply chain as there is for Douglas fir. You
Yep.
can order Douglas fir, you will get a container or 100 containers on the day that you expect delivery, and with very precise grading and quality specifications. Whether it's it's a finely graded product, and a commodity. So bamboo has to enter that level of commoditization to have a real impact. So that's what we're working on, and that's also what everywhere from industrial manufacturers to farmers to data tracking and transportation, and then also on the code compliance side to have everything actually line up to introduce a pretty new material.
Yep. Thank you. All right, we've come up to the end of our session. I want to thank Lindsay and everybody from her team for organizing this. Rod and Troy, thanks so much for joining us and for sharing your insights. And thank you for all the guests and for joining us. And I hope that you learned a bit. And if there are any further questions, I'm sure that you can send them afterwards to the organizers, and we'll maybe help answer those. Thank you so much, and enjoy the rest of your day.
Wonderful. Thank you, JP and all. For people interested in this topic, the next session within this track will be on how to actually design with mass timber products. So we'll be hearing from a designer with Wafa Thistleton and then also a designer with Ramble. So if you're interested, you can stay tuned, and you can find that link in the agenda page of the CarbonPositive website. So yes, with that, thank you, JP. Thank you, Rod and Troy. And we hope to see the attendees in future sessions.